Hello, last session of the day, one that I personally, I've got to say, I've been looking forward to because this man here doesn't usually sit this side of the camera. Rob Frazier is the man who's responsible for managing the group of highly motivated and intelligent individuals that are the evangelists at Microsoft. So bluntly, Andrew Fryer is his fault. Arguably so am I. Rob, it's a pleasure to have you here.
Pleasure.
And we've got you for 45 minutes. The reason I asked you to do this is because tomorrow is all about artificial intelligence.
Yep.
Today has been all about Azure. And obviously it's the Azure engine that powers a lot of the Microsoft artificial intelligence suites, products, research. And I was hoping that maybe you'd give us a bit of the benefit of your insight as to how that all links together.
Sure, yeah, I mean, thanks for the invite. This is going to be, hopefully this will be useful 45 minutes. If not, obviously throw tomatoes, whatever it is at the end of the session.
I'll never invite you back again.
I know, and that's probably, that'd be great. So, no, seriously, I think the subject to talk about here is, we talk a little about the intelligent cloud, and as you say, this is kind of this bridge between the world of what's Azure as a platform and the services and the richness of that. I think David and Mark went through a little bit of the sort of detail of some of the great services on Azure this morning. But how do we bridge from that into this discussion around AI? And we talk about this thing called the intelligent cloud. It's one of our ambitions as a company, build the intelligent cloud. Does that mean Azure ML? Does it mean Cortana Intelligence Suite and the IoT Suite? The area we discussed on Monday with my good friend Fryer. Is it about cognitive or bots, the overall approach to artificial intelligence from Microsoft? How does that fit into digital transformation, the impact of cloud on business? Does it mean business intelligence? So this issue of the intelligent cloud and this crossover between what is Azure and what is our AI work, I think it's an interesting thing to explore. So that's what we'll try and go through today. Okay,
right.
So if we just kick off, the starting point for this is just to be clear about what we're really talking about in terms of AI, artificial intelligence. I think Bianca and the team will get into this in much more detail tomorrow, but it's obviously been one of the hottest topics in the last few months, last 6 months in the press. We've seen the BBC series around it, for example. The key thing is not to get too caught up in some of the bigger stories and some of the discussions around things like, the malevolent side of what AI could be. So, it's very easy to get tied up with the idea that every single AI you've seen in the press or on TV or in film has somehow been out to kill us or take over the world or otherwise destroy us. That's that area of the philosophical background to AI, and it's the idea of machine consciousness and intellect. That's traditionally an area called strong AI. A bunch of researchers in that area that combine both computer science, mathematics, philosophy, psychology, and so on. But that's not really what we're about. What we're really about is what was classically called weak AI. And that really is much more a fundamental set of tools and technologies which can be used to actually implement and do stuff. So, on the screen here we're seeing a few. So, planning and scheduling systems were one of the early parts of this. Vision, natural language, knowledge representation, speech recognition, the application of machine learning to data and pattern analysis and so on. So, all of these areas have been part of the practical application of AI techniques into products, services, into industry, even down to things like the ability to do autonomous systems. So self-driving cars, for example, are a big amalgamation of a lot of these underlying AI technologies, even up to more esoteric things like swarms and things we call self-organizing systems. So there's a broad area of tools and research that go into this more application-focused end of AI, and that's really what we're talking about when we think about how we're applying that to Azure.
All right.
So, with that little setup, it's always good to have a picture of the boss. He's over here on October the 6th, as you've seen, so we're having a technical event actually for Satya. So it's a developer level event, so developer and IT pros more than welcome to attend that, and there's a sign up available. But when Satya talks about intelligent cloud, we're really talking about three key themes which we'll run through now. Our bold ambitions as a company, what we're trying to drive, this concept then of how we're going to embed intelligence into everything we do, and then finally, what does AI mean in terms of genuine transformation, digital transformation? So that's the three things we'll briefly cover off. Okay. So let's start with bold ambitions. It used to be we had a very simple, straightforward bold ambition at PC on every desk. And that was a very transformative, change the world kind of thing, which obviously built the companies to where it is. But in Microsoft now, we much more think now about three bold ambitions that we're trying to achieve. Create more personal computing, reinvent business productivity, and build the intelligent cloud, the thing we're talking about here. Right. It's probably just quickly worth just running through briefly what we mean by some of those things. So in terms of more personal computing, there's a bunch of technologies, some which surface in Windows 10, for example. Things around gaze, the ability to track eye movements and where the focus of attention of a user is. Okay. Gesture, whether it be inking, speech, identity, and so on, plus the ability to understand and interpret the emotional state of a user and the things that they're writing. So all these kind of input and output techniques in more personal computing are things which are designed to make it much easier for us to interact with and benefit from technology. It's interesting to think that actually, if you're interested in this area, by the way, and this is a real stitcher for these two guys, you know those kind of videos you take when you just catch it just the right moment and people look a bit dorkish? Yeah. Well, here's Andrew and Mike from my team. They have a show on Channel 9 called Context. Brilliant show, talks about all the aspects of more personal computing and the technology around that area. So do check that out. Highly rated show. Really, I think it goes out every week. So take a look at Context, but it's a brilliant piece of work by those guys on my team.
And they know what they're doing. Spooner's a great guy, and well, Mike is Mike, so definitely worth
absolutely.
watching.
So that's definitely worth watching. This episode, by the way, it's about gesture and hands, hence the rather goofy setup. But there we go. Anyway, outside of the Context show. Clearly, a lot of focus at the moment on a holographic platform, HoloLens, and holographic application development. What's interesting, though, is that a lot of the technologies which make things like holographic work, not the projection and the actual building of the 3D artifacts, but the ability to control and manipulate, are all based on things like hand gestures or gaze. And all of that technology has really been developed over the last 4 to 6 years on the back of deep learning neural networks, artificial intelligence. So in this more personal compute area, we're thinking about how do you recognize gaze, how do you do hand gestures, what's the emotion and the reaction of user. All of that's fundamentally embedded in this area of AI and machine learning.
I remember seeing a little while ago a wonderful session where they were talking about Kinect.
Yep.
And I hadn't realized that the way Kinect does skeletal tracking is because they trained through the use of things like AI to recognize a human skeleton. I thought that was incredible.
Absolutely, and I'll come exactly to that example with some pretty video in a few minutes.
I knew you were going to mention
it. As if this was planned. Next thing, reinvent business productivity. Now, obviously, that includes for us this big step change we've seen recently around things like Office being a first-class citizen across every platform, iOS, Android, as well as Windows, and the ability to have the right access to content, whether you're consuming or authoring it on various platforms. So that's obviously part of what we're doing around this business productivity and reinvention. But you need to think deeper. Think about we're doing with Microsoft Graph and potentially also with the acquisition of LinkedIn. We're starting to think about organizational network-like intelligence. Who's connected to who? Who's interacting with who's collaborating? What information is flowing between different parts of the organization? This kind of organizational insight, organizational intelligence, is also part of this broad move to how we think about reinventing productivity, enabling organizations and individuals and organizations to be far more productive. So there's an element there as well which starts building on graph theory and starts building on top of a lot of our data platform. And then finally, of course, we get to the third bold ambition around building intelligent cloud. Now, I want to pause on this just for a second. You may have heard, and obviously we talk about this idea, we live in a mobile-first, cloud-first world. It's really important sort of expression to understand in the sense that what we're talking here is the cloud being the glue, right? The cloud is the point of choreography, that seamless orchestration, if you like, of all those end user experiences on different devices that just seem to make those great experiences work. So the ability to edit a document on one platform, immediately pick up another device to review it, and seamlessly the place you're at, is transferred and apparently auto-magically onto the device. That kind of synchronization via the cloud means that what you end up getting is this mobile-first experience, meaning that it's the mobility, right? It's the mobility of the user experience which we're really referring to here, not necessarily just a device. So we're saying here is that in this particular world, the cloud becomes the glue between all these wonderful device-based experiences. Now, interestingly, we've only talked about this particular expression for about 18 months or so, but it's something here in the UK with the team we've been talking about a lot. I just thought it'd be funny. This is a slide from 5 years ago. You'll be able to tell that because of the youthful-looking Anton Deck on this slide. But we've been talking over 5 years about this idea that mobile apps plus the cloud, you need to think about the app as spanning both the device and the cloud. So this underlying thing around the integration of device and cloud experience has been something we've been talking about for the longest time. And it's interesting that the way that, again, this is the same deck from 5 years ago, we started talking about how at the time, I think this is was quite forward-looking at the time. We're saying about the cloud empowering the device experiences and enriching them. And one of the key places where we initially really drove this sort of message and engagement in is in the gaming industry. We talked a lot. We talked a lot to the game industry about the power of the server side,
Right.
not just from the classic kind of Titanfall multiplayer cloud hosting story that you've seen Scott Guthrie talk about a lot a couple of years ago, but also sort of more complex things. So the ability to use server-side hosting, for example, cloud hosting, to run the non-player characters in a game. So the AIs, which are the non-player characters in a lot of games, particularly the console games, they can be offloaded. They essentially run in the cloud and free up compute cycles on the device for graphics and other processing. Same way physics offload. There's a great demo that Googs and John Jushuk ran at Build a couple of years ago, showing the impact of offloading the physics calculations, the physics server from a game
I remember
onto
that
the cloud.
with the collapsing building. Yes.
Exactly.
Yes,
so the creativity you can unleash in gaming and the game experience by using the server side was part of this whole narrative of empower the device side, the app side, with the back-end power of the cloud. And the game industry actually is moving firmly in this direction also in the sense of the business models, because a lot of game studios use data analytics now to track both customer engagement and progress through a game, so they can optimize the game and do live A/B testing of different game features when the game's in the wild. So that kind of server-side sort of thing is great. But interesting, a lot of you may not know this particular story, but there was a Xbox game went out 5-6 years ago, which was built by Microsoft Research. It was called Path of Go, so the game Go. Obviously, you would have heard about Go in the news about 8-9 months ago with the work that Google did around AI with a DeepMind group playing the world's greatest Go player. Go is an interesting one. We were looking at this going back 5, 6, 7 years in Microsoft Research, but the reason Go is of interest is because of its complexity. So if you think about a game of chess, chess has somewhere in the region of 10 to the 60 possible games in terms of all the various piece movements. One estimate of the number of atoms in the visible universe is 10 to the 80, so we're getting very large numbers. The possible combinations of Go is of the order of 10 to the 700. So it's really the high bar really in terms of computational complexity, which is why the AI and computational researchers look at it. Well, a project went on in MSR, didn't come out in terms of a product offer, but it was basically about how do you create a boundless AI in the cloud which empowers the gameplay on the mobile device. So how could you play the best, highly capable AI without actually needing the supercomputer sitting on the phone? So this was a transactional system that was tested around creating AIs in the cloud to empower the mobile device. So the pattern here, as shown on the slide, is basically AIs in the cloud enriching and empowering, embedding intelligence into the mobile app experience.
And importantly, the user never knows. It's just totally transparent.
Right. And this is something we were talking about 5 years ago. So it's interesting that for us, this whole narrative around embedding intelligence and the cloud being potentially one of the places where the intelligence occurs or is based, and then enriching different experiences or more personal compute or business productivity experiences has been something actually we've been talking about for a while now. We just surfaced it recently in terms of this particular intelligent cloud language. So that's broadly a bit of context around where we've been heading with this.
Okay.
So if you think about what we just talked about, more personal compute, a lot of the technology is based on deep learning and neural networks and machine intelligence. More reinventing productivity, again, fundamentally about understanding process optimization, data analysis. And then the intelligent cloud in terms of the embedding of intelligence in the cloud and using that to reach into devices and multiple devices. Fundamentally for us, AI goes to the core of our 3 bold ambitions. The bold ambitions overlink. You can't separate productivity from device. Obviously, clearly they're part of productivity scenarios. Yeah. But its core, we have this area of AI. And so that's why really for us, we're very interested in why Microsoft invests a lot of funds and resources in our fundamental AI research. And obviously one of the centers of excellence of that is worldwide is based in Cambridge at our lab in Microsoft Research Lab in Cambridge. So given that, how do we then think about the actual definition of the services and how you could utilize this AI in the cloud for device or development use? And as you see on the screen here, we kind of think about this in 3 ways, and actually these 3 kind of tracks are additive. So we think about the IoT, data, machine learning and robotics kind of story, and I'll go into that first. Mm-hmm. Once you have that, you can build cognitive computing, and I know we had a few sessions earlier in the week, we'll talk briefly about that. And that then leads into the idea that you can then think about conversational intelligence, this conversations as a service initiative that we're running. So I was briefly going to talk about each of those 3 areas to show what the capabilities are, how they become additive, to illustrate the kind of capabilities we have in the cloud, which enable you then to take essentially AI, embedded intelligence or intelligence, and embed it into your development and into the apps and the technology which you're building yourself. Okay, good so far?
Yep.
Excellent. Okay, so with that in mind, let's talk a little bit about data. This is where I wish we had our long-range fryer sitting next to us on the couch. Andrew's been an absolute advocate around the whole area of data for a majority of his life. We live in a data age. It's interesting the way that data comes from. I have teenage daughters, so as far as I'm concerned, 99% of the world's data is being generated by selfies. I'm sure the world's cloud data centers are full of pouting shots of various teenagers. On top of that, though, there's just the exhaust we get from mobile apps. So, whether it's gaming or others, we're increasingly just generating this massive exhaust of data with everything we do, and telemetry, which is then being used to drive better customer experience or better gaming experience, whatever. There's the idea of self-quantification. We increasingly want to take data out of ourselves, right? Whether that be through wearables, medical devices, whether it be our habits, whether it's the way we're trying to look at how we optimize our own time. So that personal kind of quantification, the quantification of self, even down to things like genomics. So we've got that whole kind of screw of things. But one of the interesting areas where we're going to see a lot of data, of course, is from the Internet of Things, right? And at this point, I need to get something off my chest.
Okay. Go on then.
So the Internet of Things, if you report by Gartner talked about how over the next, I think by 2025 or something, Internet of Things will generate 9 trillion in new economic value. And that's a highly plausible number, fundamental change. Wave 1 of the internet was connecting computers, wave 2 was connecting people, wave 3, the Internet of Things, is about connecting everything else. So it is a fundamental shift. Okay. The problem is, when you then get into cases and say, well, what do you do with it? The immediate thing you tend to hear is, oh, I know, let's connect our fridge up to the internet, right? Or let's take the toothbrush and have a toothbrush which tells us when we brushed our teeth.
Yes, or an internet-connected light bulb, but I still haven't quite grasped the notion of yet.
So the problem is that we end up with this internet of trivialities, which is no offence to, if they're watching, any refrigerator manufacturers or people, it's just that the 9 trillion economic value is not me knowing whether the blancmange in the fridge is out of date or not, right? The real Internet of Things looks very different, right? The real Internet of Things is basically extremely simple, right? It's about taking the world, digitizing some part of it in a way that's not been technically or economically possible before, and IoT technologies are fundamentally about that extraction of data potentially from the physical world. One of our guys, Paul, talks about this as being, think of the IoT as the ODBC driver for the cloud, right? Getting data easily out of the physical world into the cloud. So you mine data in the physical world, get it into the cloud, you then do some analysis on it and apply some intelligence to it, and then critically you then make a decision to do something differently or better, which you then feed back into the world, right? Now, if there's any control engineers watching, first of all, for me, control engineers are the creme de la creme of the engineering space. But they're now looking at this picture saying that's basically a feedback control system. You take sensings, you have a model, you apply actions back to it and change the inputs to the system. Exactly right. Control systems are designed to drive better outcomes, designed to provide optimal outcomes or optimization control problems. So it's interesting for me that I think about the Internet of Things much more from a control point of view, which is how do you take data, do something with it, and effect a change back in the system, which improves outcomes, makes things run more optimally. And that outcome could be, I don't know, better temperature control within a building. It could be optimization of your logistics chain. It could be better control of your oil fields, whatever it is. Better productivity on your farm, right? But it's fundamentally, that's the outcome, right? And when you take that view, a few things look a little different. There's two kind of outcomes of that which were worth briefly mentioning. One is this idea of everything as a service. So the idea that fundamentally, Internet of Things enables us to think about physical objects as becoming more service-like. So, you've probably seen the case study we've done with ThyssenKrupp, the elevator lift manufacturer here in the UK, of course. Use the UK nomenclature. That's the idea of taking something which was previously sold and installed to being something which, on the back of predictive maintenance and better analytics around the actual lift itself and how it's performing, you can turn it much more into service. Potentially, at some point, you could even think about changing the way that you price and deliver that. You actually deliver an SLA. I'll charge you a microtransaction for a number of lift journeys in your building, rather than you paying for the purchase, installation and maintenance of it. So whether it's this, you would have seen the stories we put out with some customers around things like jet engines and so on. The point is taking physical objects and thinking about different business models around them, which turn them more into service like a subscription model. And that's enabled by all this technology. So that's fantastic because there's nothing more disruptive in the market than the new business model. Right?
Okay.
The other area, and this is really esoteric, is termites.
What?
So so far we talk a lot about getting data out of the world, getting it into the cloud, right, make a decision. But let's not forget there's patterns in IoT where some basic intelligence exists at the nodes, the endpoints, the devices. And something which hasn't been explored greatly yet, but was really interesting for me, going back to my background and my AI PhD, is around this idea of distributed intelligence, because Internet of Things is also technology to connect, seamlessly a huge number of disparate, simple computing devices into a coherent system. And that's why we talk about termites, because they're very simple processing, very simple nervous systems and neural networks in their nervous systems. Yet, by the nature of their interaction and the sort of non-linear interactions between the individual members of the society, they're able to achieve some quite staggering things. I mean, these termite hills, they actually have cooling systems built into them. There's beneath the ground, they have essentially structures which enable the moisture in the ground to create cooling flows of air through the termite hill, right? These are little bugs, but there's a collective intelligence around them. So one area I think we're going to see emerge in the next few years is the area of how do we create distributed self-organizing systems off the back of Internet of Things technologies, and that's going to be real fascinating to watch. So that's the kind of embedded intelligence that's embedded across a network within the system. So that's going to be really exciting.
Yeah.
So anyway, machine learning. Core of all this is this technology called machine learning. It's been, it really kind of accelerated about 5 to 6 years ago on the back of the initial work around deep learning neural networks. And it's got to the point now where we can do things like Skype Translator, where we can do real-time conversational translation of languages between different pairs of languages, and a fantastic experience. It's amazing to think how far, though, that we've come in the last few years on this. And you mentioned Connect, for example, a little video playing now. So as the point you made is that Connect is an amazing piece of kit. The work was done in Cambridge, MSR Cambridge. Essentially, the way that Connect worked was nobody programmed it to recognize arms and build a sort of a strawman model of someone's frame and then track the hands and so on. Basically, millions and millions of generated sequences of people doing this were essentially trained into a deep learning neural network.
I just thought that was incredible when you watched that.
Yeah, and so in effect, that's how you can create a piece of technology which enables in that first instance to track skeletons. In the Xbox One Connect, some of the other remote sensing capabilities, it's so sensitive, for example, it can track your heart rate. Using the infrared signature variations on your skin. And so that ability to use training to vast amounts of training data to create these networks which then form these kind of tracking and other capabilities is really good. And I can illustrate this even further by talking about my dog. If you just give me a second. So this is a bit of fun. You can try this at your next party or whatever. We've got a little site called What Dog. There's also an iOS app called Fetch which does this as well. Okay, and what basically enabled you to do is, if I just go down a bit, I can get a photo of my dog. Let me get my dog on the beach. And he's a Labrador. I wouldn't say smart, but anyway, he's a Labrador. You may think, oh, that's interesting. Let's just try another quick one. Here's your photo. I'll get another one of Buster's skin with his Christmas ears on. There we go. In this case, the thing is vinyl armor. For those that love dogs, Buster's a gun dog line of the Labradors. He has much squarer jaw than some of the other Labrador species, more pointed, so that makes him look vinyl armor-ish. But the interesting thing is at least it's identified him as a dog, not a reindeer. Many years ago, classical AI models would have seen this shape with that kind of, you get it there with the antler structure and said, oh, that's a deer, right? So it's smart. The interesting thing about this is that actually you can also do a few other quick things with it. So if I just get another photo, it's a bit of fun here. Let's get this reprobate here. So apparently you're a burbole. I think I pronounced that right. Protective nature can cause damage when jumping. Sociable and obedient only after training.
Do you know what? I think a lot of people would agree with that. Yes.
Yeah. And just to complete this, so let's just get another one just for a bit of fun. I think a lot of you, or some of you will know Claire, who runs our MVP program. Let's just see what Claire is.
See, I wouldn't be
She's an
brave
Afghan.
to do that.
I asked her before. Apparently, Claire is aloof and requires daily brushing, according to this. So that's all good fun. But the point here is that there's a serious point to all this dog stuff, which is that no one, again, this algorithm wasn't told what a dog was. Thousands, hundreds of thousands of images of dogs were shown to one side of a neural network. The other side was told, here's what these are, Labrador, Afghan, whatever. And the network learnt. It was trained such that now you can show it, with a high level accuracy, a picture of a dog, and it will high level accuracy tell you what kind of dog it is. So that was one of the things where you have lots and lots of labeled data and you create the capability. And what we've been able to do is move that to another level. So we've got these cognitive services. Again, if you've seen these earlier on in the week, this won't come as news. But we have a bunch of APIs now on Azure which you can go to and do things like computer vision. So for example, let me do this. This is a great one. Let me just pick up a photo here. This is important to me. So this is a photo. It's my son in front of something. You know what that is, Rick?
I do. That looks like an SR-71 Blackbird.
SR-71 Blackbird, spot on. Which is actually, we recognise it because we can see it's black, it's got a particular shape, you see wheels, so that's that. Interestingly, the algorithm is saying, if you look at the top right here, a boy standing in front of a plane. Oh, wow. I think that's pretty impressive. Right?
It is, because it's not like you can see a wing on that, is it? It's a pretty
exactly, yeah.
shape.
You can see the intakes angle slightly down to allow for the flow regime you get when you get into the high supersonic flow regime
I love the fact that it leaks. They can just about get enough fuel in it to get up to refuel.
Because it grows by about 12 inches when it flies, right? Because of the thermal expansion. That's right.
So that was built in 1950 something.
An amazing piece of engineering. So, and interestingly, there is a gag here as well. My son's wearing a Transformers T-shirt. So for those of you who have seen some Transformers films, of course, that turns into Jetfire. So there's a whole depth of storytelling here, which is just amazing, right? So anyway, we'll go with that. The point is here, though, we've got a bunch of these APIs which enable you to take previously, this will be fun, previously difficult, extremely complex forms of AI processing and turn it into a API call. You can do in Node or from ASP.NET. Okay. So, for example, this is a mood one. So apparently, this photo of you is predominantly happy, about 50%, a bit neutral. But interestingly, there is a reasonable level of anger, and disgust, and a little bit of contempt in that face, right?
So I know who took that photo, and at this point he's going, you know what, that just sums up our relationship.
So, and look at these APIs we can do emotion, facial recognition, you can look at videos, you can do language understanding, you can understand text and linguistics. There's a whole bunch of capability, and you can embed in your apps, right? And actually add those capabilities literally with a couple of lines of code and an API call.
So
right?
I mean, I know that other people at Black Marble have done things just like that. We've used some of those for the speech translation.
Absolutely.
And it's just, we never could have built that before ourselves because we haven't got the resources there, even if we had the people.
So that's one of the aspects of this intelligent cloud idea, is the fact that we can take all of these really dynamic, creative capabilities, advanced capabilities, productize them, put them at a price point which makes them easily accessible, and get them integrated into apps and solutions. Embed that cloud-based capability into the application experiences. So that's pretty important. And this deep learning area, it really is fundamentally about this issue of data and then the intelligence. You need the data. You need all that labeled data sets to do the training of the network, so it can be discriminative, as in it can then discriminate between inputs and give you an output. But the way that which researchers do that now is also by then generating those training sets like we did with Connect. So AI researchers will talk about discriminative networks, which is when you sort of determine what the output is based on the inputs, like what the kind of dog is. But then you have generative approaches, which are then ways of training the networks using data which you artificially generate.
And I guess one of the important things there, if you're nervous about that whole singularity thing, that what dog, it's not continuing to learn, is it? It was trained and now it can only answer the questions.
But if you provide it ongoing with continually tagged data and labeled data, it can continue to improve and learn. Absolutely, it could do that, absolutely. So back to the dogs. Embedding cognitive computing. So very quickly on our little map of AI services, we've gone from IoT data and robotics and ML, one level, but from the data to the intelligence discussion gives us these cognitive capabilities, cognitive computing, which are able to embed. So very quickly, once you've got machine learning and data, you can generate cognitive computing. And there's a whole bunch of stuff around deep learning, things like CNTK, which our toolkit, which Bianca Fortuna and my team will talk about tomorrow, where you can also do your own customized machine learning to create your own sort of cognitive APIs, if you like. So that's really fantastic. So, excuse me. So that takes us from data through to cognitive. Once you've got cognitive, and we can understand speech and speech and text and emotion and faces, it opens up the opportunity to have human language as your UI.
Okay.
Not just spoken word, right? If you look at this picture here, you can infer a lot from this. They're clearly friends, right? You can tell some of the emotional state, what they might be sharing. So that's something we do intrinsically because we can recognize non-verbal forms of human communication, body language, and so on. What's interesting, the computers can now do this and think about the fundamental shift which this is referring to, which is that for years and years and years at school, you had lessons, we all had lessons to learn how to interact with computers, the keyboard, the mouse, programming, Excel, and so on.
Yep. Now,
the computers are learning how to interact with us. It's a fundamental shift. Right? And so this leads the ability to engage in human conversation, leads this idea that what we're calling conversations as a platform.
Okay.
The idea that going forward, the model is going to be, there's going to be three actors in these kind of technology-enhanced conversations. There'll be the person, so yourself. There'll be your intelligent assistant. I can play the role of the intelligent assistant today, maybe. In our case, that's Cortana, of course. And then a whole bunch of experts, if like specialists, which interact either directly with you or with the intelligent assistant to achieve outcomes, and we call those bots, right? So we talked a lot, and I think on day 2 we did TechDays and I did a whole bunch of stuff with the team around conversations and platform and the bot framework. Mm-hmm. But broadly, we have this area now where we're working hard to build out, extend Cortana's capabilities and make Cortana extensible, so the virtual assistant. And then from there, the ability then to obviously think about bots as the new apps, right? The ability to essentially have APIs and chat interfaces across multiple channels, whether that be over Messenger, whether it be over Skype, whether it be over Facebook or whatever. The ability to interact with these bots as experts to achieve particular outcomes and do transactions, whether that be booking your flights or whether it be getting tickets or understanding your tax position, for example, with the unknown revenue. So tons of things which these bots can, which these new apps can do.
I think the important thing there for me actually is it's another one of those shifts in how you approach this, because you're my assistant. You're not the source of all of the information. If I say to you, Rob, how do I make a coffee? Well, a human being will go, I have no clue, hang on, I'll go look it up. And what we need to do now is train you, the bot, to understand what I've just asked and go and find the appropriate expert, and that appropriate expert has to only interact with the bot and then come back and give me the answer.
Yeah, I mean, and this is where context and understanding intent becomes critical. So I could say to you, for example, tell me about Sharm el Sheikh, right? Now I could be asking that for a number of persons. I could be, and I like scuba diving, so if you knew as my assistant that I was into scuba diving and I asked that question, you'd immediately think, well, here's the dive operators, the weather conditions, availability, etc. of diving there. Yep. Whereas if I was studying the history of the Sinai and the geopolitical history of that part of the world and asked that question, you'd give me a very different form of information. Yeah. So understanding intent is critical in that, and that's where a lot of the work which we do in AI starts looking at how do you understand the intent of what we're asking, which is why a lot of this technology comes out of our Bing team, right? Because fundamentally search is about intent, right? And search results about meeting the results which you then back to a customer or a user based on the intent of what they're trying to get to for the search. So it's interesting to sort of tie up to the technology areas. So yeah, spot on. So I think new apps are great, and in fact, if you want a little party demo, you may or may not have seen this particular one. There's a bot called Murphy which you can interact with via Skype. Okay, so Murphy is an interesting thing. Murphy only responds to particular questions which are what-if questions. So for example, I could say, what if Margaret Thatcher, if I can type, was a Greek goddess?
You realise that typing that in has just aged the pair of us.
Almost certainly. Greek goddesses, absolutely. And you get back a picture, and we can open this up, have a quick look, hopefully. It looks like, there you go.
Fantastic.
That's not the best one, but you get the idea. And you can get really creative with this. There's all kinds of fun you could have. What if Barack Obama was a ghostbuster? Let me try this one out.
You said what is there? Sorry.
Yeah. What if this is got to be done, right? Obama was a ghostbuster. Is that better?
Yep.
Come on. Here we go. Let's see. Oh, this is interesting. I can see Slimer.
Is this new Ghostbusters
Cancelled.
or classic Ghostbusters?
Here we go. I don't know about that. Anyway, you get the idea.
It's definitely a Ghostbuster.
It's all good fun. Exactly. So again, look at Murph. That's a great little part of it. But you get the interesting there is that it's a simple example, but underneath it, think about the complexity of what we're asking. It's got to take different information, work out the context, and understand how to merge those into something that actually becomes an interesting experience for the user, right? So,
and I mean, coming back to what you were talking about, disruption. Of course, it's changing potentially how we act as businesses. I don't have to write the app to talk to you. Yeah. I write the app to talk to the bot, and I can focus on I don't know what I do well, finding you the best sugar on the planet or something. And that specialisation means I should be able to get better at it, get more efficient, make more money.
Absolutely. So I think this is in conversation intelligence is what sort of area of research call it. Human language, bots being the new apps, and digital assistants being meta apps, if you like.
Yep.
But this idea of the intelligence starting to be embedded into every transaction that we do. So that's what we're pushing, that's what we're doing with this conversation as a service offering, which is the sort of top tier of our sort of AI engagement at the moment. So with that in mind, we kind of done that quick walkthrough. It's interesting, how does this then translate into other parts of our intelligent cloud narrative? So we talk about digital transformation. This comes back then to the story, our final point, which is what's the real impact of this? Right? It's great stuff. We can identify dogs, and we know that you're a weird breed of dog that needs training for it's sociable, and we can merge images of celebrities and Greek gods. What about digital transformation? So it's interesting if you look at the narrative that we talk about around transformation of business. We talk about empowering employees, we talk about engaging better with customers, improving business process, and obviously innovating products and services. A lot of this AI technology we have, and the data layer, the cognitive layer, and the conversation layer impact intimately and deeply on all of these areas. Right? Okay. So you can take a little walk through this. Better products and services. The ability to embed intelligence into your products and services means potentially that they're more capable, that they can interact and provide better customer experience. Right? Potentially, it enables you to even change the model at which the business model by which you're selling those products, those particular products, turn them more into services. Right? Yeah. Your Lyft as a service example. So the innovation by embedding intelligence into products and services essentially creates much more value, enables companies to think more about how they create better value for their customers and shareholders. Right? On the thing you're touching on in terms of computational intelligence, we have the opportunity now to think about ubiquitous service personalization. Right? So the ability on the back of, a lot of companies have know your customer systems, right? But tying that in with the ability to have a conversational interface with the customer, and also a conversational interface which goes with them, so they could start a chat on their on text, they could move to WhatsApp, they could then move on to Messenger or Skype, and it's a seamless interaction. But in addition, actually understand how, just like a call center handler would do, the emotion of the person, how they're reacting to the experience they're getting. It creates the opportunity to put access to services and product support at a new level of scale and a new level of quality. The always-on personalised sort of customer service agent for a lot of businesses, which is why we're seeing an awful lot of interest from enterprise organisations around this particular area. It's a really hot area for us at the moment in terms of where we're looking at doing early adopter work and proof of concepts.
Okay.
Automate business process. Clearly, a lot of the data, we talked about this in the context of IoT, but the ability of AI to automate business processes and use the intelligent cloud to make processes more efficient and more optimal. Clearly, that leads to a strong set of business outcomes.
To be fair, I'm a fan of, I know the Office 365 guys are using a lot of this kind of technology, things like clutter.
Yep, absolutely.
Which that makes such a difference to me because all the crap disappears somewhere else, but it's not junk. So I need to look at it just later. Absolutely,
and that ability to and the irony of this, of course, is that the more access to information we've had and the more flows of information we get, the more easy it is for us to fall into habits and ways of working which are completely and utterly suboptimal. If you look at the tips for high-performing individuals, one of the key things is don't try and multitask. If you need to be on task, stay on task, get into flow state with the task, don't allow the constant communication and flow of information to interrupt you. I think actually this reinventing productivity story we have, and you talk about clutter, does get to the core of how do we work in tandem? How do we augment individual capabilities with the technology in a way which leads to better outcomes, as opposed to us just feeling like we're being flooded by the information that flows out of the latest technology which we have. So yeah, I think that's a really important point there. Critical also is this idea of moving from batch to real-time business. So I used to work in the city, at the banks. At the time, most of the risk calculations, those banks would at best be overnight runs. So get the closing positions when markets close, run a whole bunch of number crunching on it, and at the end of the day, come back with risk numbers so that you knew where you could trade the next day. Increasingly, those things can be done real time. The cloud provides essentially limited to unbounded compute capability. And whether it's in that particular scenario with high-performance compute, or whether it's just with data and stream analytics, the ability to use machine learning to identify subtle signals and patterns in petabytes of data flowing past you, it means that businesses can increasingly move from thinking about batch decision to real-time decision-making, real-time optimization. Again, that really provides a lot of enhanced business value and that digital transformation. Okay. this is one of my favourite, reducing the cost of uncertainty. One of the biggest costs in business is literally planning for uncertainty. Now, if you're launching a major game, for example, right, how much cloud capacity or server capacity you need to support the game launch, right? Yeah. And in the old world, you had to basically make an estimate, buy the servers, rack and stack them, plug them in, and you're ready. In the cloud world,
hope,
exactly. In the cloud world, given deployment times, you can more or less ramp up and ramp down based on demand, which basically means you're taking away a lot of the risk and uncertainty in those decisions you make. Same for a retail outlet, which needs to think, okay, how many workers do I need in on Saturday in the shop, based on predictions around weather patterns and footfall and what's going on TV and in sports and so on. So this reducing cost of uncertainty actually it's a way of taking out a lot of costs from businesses in a way which enables them to, again, focus resources on more important or differentiated activities. So, and this then, the final part around the AI story really and the intelligent cloud is it should lead to a step change in productivity if applied right. Both in terms of the individual worker level and individual workers, in terms of the way that we interact with customers, in terms of the way that we build and deliver products, and in the way we optimize our own processes. So this kind of AI thing and the productivity story goes to the heart of this digital transformation. So with that in mind, what I say is we've gone through aspects of the intelligent cloud. In fact, it's not just Azure and it's not just Cortana Intelligence Suite. It's this whole pattern of having intelligent capabilities in the cloud, which can then be embedded in mobile apps, customer interaction experiences, products and services, and so on. And we talked a little bit about what we're trying to do around the data and machine learning element, and then how that creates cognitive computing capabilities which are easy to access, and how we're now extending that now into a conversational platform. What's our relative roles in this between us and our customers? So our role is one of democratization, always has been. This is our main goal here, whether it be cloud, whether it be AI, is to take these very powerful capabilities and make them accessible to the individual. There's also a subtle part here, which is one about democratization of scale as well, which is that it used to be if you wanted access to 100,000 servers, you had to be a major financial institution or an oil company. Now all you need is an appropriate size credit card as your subscription. Right?
Yeah, and I think that's a big point for me. I mean, as a small organization, the fact that I get an enabler in two ways, because I could never really afford to develop that really clever AI technology, and now you're offering it to me as a service that I can exploit. But also I could never afford the infrastructure. So if I've got my great idea app, you've now enabled me to build it, but I can also deploy it in such a way that it'll scale for demand. And if I've costed it right, as your million servers comes online, it's because I've got enough people giving me money to pay for it. And that, it's enabling what previously would have been a little guy who'd had to try and shop an idea around and it would get shot down, to come up with, I don't know, the next Bing or the next Google or the next Amazon.
Hence my favourite dog picture, which is the idea that the little dog's able to run with the big dogs thanks to this complete technology. So democratization, that's our role. We're going to democratize access not just to cloud scale, but also to these advanced capabilities and put them in the hands of individual developers, right? Okay. How should our developer audience think about this? Absolutely focus on differentiation. So, and this probably more applies at the enterprise sort of department level, maybe individual devs, but there's no point building technology or investing technology unless it's core to your IP and differentiates you. You know, we are going to be commoditizing and democratizing access to such advanced technology capabilities in an accessible fashion that really then it says, okay, take what we've got, build on it, and extend it. And that idea of build on rather than build inherent your own capabilities, I think, is really critical going forward to how we'll see customers and developers really leverage what we're doing with the intelligent cloud.
Standing on the shoulders of giants.
Absolutely. So, summary from me, I think, and this is pretty high level. We hinted on this through. So, in terms of our artificial intelligence kind of story, intelligent cloud, we're on about embedding intelligence from the cloud into other experiences. At a high level, though, let's just be clear: we're not thinking about replacement. The idea of the super intelligence is taking over the world. It's for augmentation. In fact, we're going to explore this whole subject of how do we augment human capabilities with technology at Future Decoded. It runs through the entire of our technical day. We're talking a lot about the augmentation of around AI and other technologies. We need to be able to trust the technology, and this goes to the core of a lot of what we're doing around UK cloud at the moment, and our work on privacy and regulation. And as an ethical point for the company, we believe in bringing the best about technology to humanity, not the worst. And I think that's a really important dialogue when we talk about AI. And with that, I'll pause or stop.
See, I knew there was a reason I wanted to get you this side of the camera. So I really enjoyed that. It was a great and interesting and informative session. Hopefully you, the audience watching, that's whet your appetite for tomorrow, which segues nicely to the fact that we've reached the end, oh no, again, of another fantastic Azure Cloud Tech Days Online. Big thank you if you've stuck with us. Hopefully you've enjoyed it. There have been some good speakers and good sessions today, not least of which my friend Rob. Tomorrow is about AI. Bianca Fortuna and various colleagues of Rob's and friends of mine from DX will be talking about that interesting, thorny, complicated and wonderfully enlightening subject. So please tune in again from 9:30 tomorrow morning. And that leaves me with nothing to do but to say thank you for watching, draw the proceedings to a close. Big thanks to all of our speakers. Please tweet, tell us what you thought about it, suggestions for what we do at the next Tech Days Online, what puppy I've got to be compared to, what tie I've got to wear, or which box we should put Mr. Fryer in. And with that, thank you very much, and we're done.